So if we go back to that diagram that I was showing the workflow, okay, the tenant networking is the portion on the left. Okay, the networking is going to define the VRF. The VRF is going to have one or more bridge domains, which effectively are VLANs. They're like broadcast domains. The bridge domains are going to have one or more subnets. Okay, subnet is going to be where the default gateway is defined for the end host. Okay, then we have the policy. The policy is going to be the application profile. Application profile is going to call the endpoint group. Endpoint group is going to call the contract. Contract is going to call the filter. Filter is going to have a subject. Okay, we don't necessarily need to define all of this, but the object hierarchy is there, assuming you want to implement all of it. Okay, in this example, we're going to put both ports into the same endpoint group, which means we're not going to have to apply a contract and a filter between them. Then we'll look at, in later examples, how do we do inter-EPG communication, and then how do we do layer 2 connection, how to do layer 3 connection, and so on and so forth. Okay, but the most basic example would be two end hosts in the same endpoint group, no contract between them, they're in the same subnet, in the same bridge domain, in the same VRF, in the same tenant, then they should be able to send traffic to each other. Okay, so next we're going to go under application profiles, and we're going to create a profile. Okay, and actually let me go through the wizard here, and let's see, it's probably going to, let me see which objects it's going to create for us. So let's say we want to create a tenant with a private network. Okay, tenant with a private network basically means a VRF. So specify the tenant name, security domain. Actually, no, that's what I already did. Okay, so the tenant is created. Create an application profile under the tenant. This wizard's not actually doing anything special. The only thing it's doing is just going under those sections and then saying create application profile. It's the same screen. Okay, so let's say that this is going to be Brian app 1, and we'll create an endpoint group. Brian EPG 1. We need to create a bridge domain. Bridge domain, we'll say Brian bridge domain 1, which is in VRF. We're going to create Brian VRF1. Okay, any of these that you create, you can always come back and edit them later. Okay, so we have the VRF. And actually, I clicked the wrong button. I clicked on BGP address family. This will come back to later. That refers to layer 3 routing, but we can skip those. And okay, same with the EIGRP. Okay, so we have the VRF. And there was a question here. So is it true to say multiple subnets configured in a bridge domain is the same as having IP secondary addresses? Essentially, yeah. So in normal network design, you would think of that as bad practice to have multiple subnets overlapping in your same VLAN. Within the case of VXLAN, not necessarily, because, or not even within the case of VXLAN, but within the case of ACI, it doesn't even really matter because your VLAN number, it has only port local significance now. So I'm using 1234, but it doesn't necessarily mean that 1234 on leaf 1 has to be the same as 1234 on leaf 2, because what really matters is how is it mapped to the VXLAN number on the back end. Likewise, I could have two hosts. Okay, so let's say we have host A, host B. Those are representing IP addresses A and B, MAC addresses A and B. I could have a case where they're in the same subnet, in the same bridge domain, in the same VRF, but they don't have communication to each other. Okay, likewise, I could have the opposite. I could have the case where they are in the same subnet, in the same bridge domain, same VRF, they do have communication. You could have a case where they're in different subnets in the same bridge domain and can talk to each other. Different subnets, different bridge domains, and not talk to each other. Basically, any option that you want, you can configure it that way. So I'm not really sure why they implemented it that way, where there's not a strict one-to-one relationship between bridge domains and VLANs, or not, it's not bridge domains and VLANs, but subnets and bridge domains, but you can configure it either way. Okay, whether you're on the same subnet or not is ultimately not going to matter, because the traffic can be layer 2 VXLAN bridged, or it can be layer 3 VXLAN routed, and the spines aren't going to care about it because they're still seeing it as an IP packet anyways. It just depends on what is the VNI number that is getting encapsulated on the back end. Which in my opinion makes the system even more confusing, because you can't really map traditionally what we're used to, the regular networking restrictions or design best practices, to the ACI. Okay, so we have the VRF. VRF is then I'm going to call a subnet. Specify the bridge domain for the VRF. Subnet is going to be 10.0.0.254/24. Okay, the scope of the subnet, we're going to go through this in more detail later, but basically what this means is, do I want this subnet to be isolated so nobody can talk to it? Do I want to advertise it to the external layer 3 network, like the internet or the WAN? Okay, this would basically be doing a redistribution of the local network into multi-protocol BGP. Okay, it's doing a redistributed connected. The third option, shared between VRFs, means, do I want to do route leaking? Okay, and there's multiple ways to do this. The default behavior is private to the VRF, which means that you cannot hit it from the outside. Okay, only if you do external advertising can you actually hit the WAN. Now, the use case for this would be that, let's say I have my web server and I have public clients coming in. The subnet that the web server's endpoint group is in would be advertised externally. Okay, so I redistribute it into BGP, BGP advertises it to OSPF, OSPF advertises towards my WAN routers. Okay, but now the client comes in and hits the web server. On the web server, I want it to be able to call the database. What I would then do is create another subnet that the database is going to be in, make its subnet private to the VRF, which means it's not redistributed to the outside. The end result is that the client on the public internet can't hit the database regardless. So we can forget about SQL injection attack or something like that, because they can't even route their traffic there to begin with. Okay, but unfortunately the terminology of this is not really 100% clear in the documentation. Okay, but private to the VRF means don't redistribute it into BGP. Advertise it externally means redistribute it in BGP. Okay, the other stuff we'll talk about later. Okay, L3 out for route profile. This is going to be when you actually go to advertise it to the external network. A routed network, they call it L3 out. Okay, the rest of this we can leave as default, okay, because we're not doing any layer 3 routing yet. And then monitoring we can skip. Okay, so what that did was to create the bridge domain, it created the VRF, it created the subnet. I could have done that all as separate steps. It's just that the wizard allows you to create it all in one place. So you make sure that you're not forgetting to connect the objects, because it's automatically doing that when you create it all in one step as part of the wizard. Okay, the domain was previously created. Okay, VPC to 7Ks. Okay, before we go on, let's look back at the diagram for the logical connection here. So what I was saying is I wanted to create the application profile as part of the wizard. It asked me, what do I want to call the endpoint group? Okay, I called it Brian EPG1. It then said, what was your VRF name? Created the Brian VRF1. It said, what's your bridge domain? What's your subnet? Now it's asking me, what domain is it part of? The domain is calling the VLAN pool that was already created under the fabric access policies. The domain is calling the attachable access entity profile, which is called from the interface policy group, which is called from the interface selector, and the interface profile, which calls the switch profile and the switch selector. Or in other words, I'm applying this application profile to leaf 1, port 1/1's virtual port channel. And likewise, leaf 1, technically both. Leaf 101 and 102, port 11's VPC, and then the second VPC that's going over to 7K2. But only because I had already created the domain, and the domain was called to the AAEP. Okay, if you forget to do this step or this step, then the tenant tab is not connected to the fabric tab. Okay, so I should have put everything actually under one umbrella, which is all this. Okay, all that is defined under fabric. Okay, so the domain is VPCs to the 7Ks. Okay, where am I actually applying this? This is applied. No, let me see. I don't know if I can actually do it this way because well, let me try it and see if this is going to work. Let's say 101.1.1 to 2 and 102.1.1 to 2. Okay, so it's the first two ports on both leafs. Static path VLAN, another thing, I don't know why they would name it this way. For the VLAN, you would assume you could say 1, 2, 3, 4. Notice the red arrow box there. The naming convention here needs to be literally VLAN lowercase dash 1, 2, 3, 4. Okay, or VXLAN. Okay, but in this case, we're not calling it VXLAN, we're calling it static path VLAN. Provided contract, consume contract right now is nothing because we're not talking to any other EPGs yet. And then submit. Okay, let's see if it gave me a fault. Hopefully it did not. Okay, so under the app profile, we have Brian app1, application EPG called EPG Brian EPG1, which has the subnet, actually the subnet's called under networking, which should call the domain, which is VPC to the 7Ks, and we're specifying that the ports are configured as trunks. Okay, so this I need to edit, and I don't know why it doesn't give you the option when you're creating what port it's bound to, but I'm not doing tagging on the other side, so I want to change the encapsulation mode. It can be used to modify multiple static paths at once. Okay, so let me say all 4 of these. Change the encapsulation mode. You must select passwords in the same node. Okay, so let's say node 101, ports 11 and 12. Change the encapsulation mode is access untagged. Okay, same thing on the other one. So basically what this is saying is that this is the native VLAN on the port. Okay, for layer 2, the port is always trunking anyways. It just depends on, is the tag carried or not. If it's not carried, it's the same as being an access VLAN or the same as being untagged. Okay, so it's untagged on both. And looks like we don't need to submit there. Okay, so let's see what the end result is from the 7Ks. Okay, it may take a minute to apply, so let's go back and make sure this is correctly connected. So we're saying that the endpoint group is applied on these physical ports VLAN 1, 2, 3, 4. And actually, I should have changed the deployment to immediate, which I don't think I can change that now. That we'll talk about later. So the EPG is calling bridge domain 1. Bridge domain 1 is going to be under networking. Okay, so networking contains both the VRF and the bridge domain. So we have VRF1 and bridge domain 1. Bridge domain 1 is called from the VRF, and it should also be calling the subnet. And then under the application EPG, under the domain, we have the physical domain. Okay, let's see, can it reach it yet? No, let me try pinging the gateway, ping 10.0.0.254. You know, I'm wondering if the way that it asked me in the wizard, I think it needs to be applied to the VPC as opposed to the physical link. Okay, let me try this. Let's delete where this is applied. And under static binding paths, let's say action, deploy EPG on port channel, virtual port channel, or interface. That's what it is. So you'll see that in some cases you kind of back yourself into a corner where not all wizards will give you all possible options. And if you don't know that that's an issue, then the end result is like we have here, connectivity is not going to work. So it was trying to apply it on the physical port, but the problem is I have these interfaces in a channel. And there was no option under that previous wizard to do that. It said just whatever the static path was. Okay, so I need to say it's applied to the virtual port channel. And you can see what the names are. So it was called from the wrong object. The primary VLAN is VLAN-1234, untagged. Or not primary VLAN, port and cap. Primary VLAN means for private VLANs. Okay, so which one was this? This was 1.1. Okay, so that should be 7K1. If we go over to 7K1, the end result of this should be that it can ping the gateway, which it can. But it should not yet be able to ping 7K2. The reason why is that the endpoint group is not yet applied to that other VPC. So if I was an end host, I would be pointing my default gateway to 10.0.0.254, and then regardless of which leg of the VPC is up, the gateway exists on both sides. So on the back end, the leafs are not running HSRP with each other. They're basically just proxying for the same MAC address in their ARP responses. Then when we go to VXLAN encapsulate the traffic, the destination MAC address is thrown away anyways because we're rewriting the frame into a layer 3 VNI in order to route it to another segment. Okay, if it's bridged, it's bridged. We don't need to worry about going to the default gateway. But if it's routed, it's the same exact logic as we talked about in BGP EVPN, that the MAC address of the default gateway now becomes a link local attribute. So it doesn't matter that it's being reused over and over and over on multiple leafs. Okay, so essentially all leafs own 10.0.0.254. Okay, so we're now under tenant app profile, the app profile, application EPG, the endpoint group, static bindings, actions, deploy, endpoint group on virtual port channel. Virtual port channel is number E12, okay, which again assumes that you know whatever your naming convention was. The naming convention here was auto-generated by that previous wizard. And once you create the object, you cannot change the name, just like in UCS. You'd have to delete the object and then recreate it. Okay, port encapsulation is VLAN-1234. Mode is access untagged. Okay, so now we should be able to see that 7K2 should have reachability to the gateway. Gateway is 10.0.0.254. And we should now be able to ping 10.0.0.71. Okay, or likewise telnet to it. Telnet 10.0.0.71. Which is 7K1. Okay, if we look at the show IP ARP and look at the same thing on the other side, show IP ARP. Okay, both of them have the same gateway address, the 19FF. Okay, now let's say that we were to have some sort of failure event. 7K1 loses its link to leaf 2. 7K2 loses its link to leaf 1. So we're now only going to be singly attached. We're going to be singly attached in this direction. So 7K1 is over here. And then we're going to be singly attached over here. Okay, 7K2. So on 7K1, let's go to interface E18, shut down. On this guy, interface E17, shut down. Okay, let's look at this on the 7Ks and also on the leafs. So from the APIC, we're going to go to the bash shell, show fabric membership, attach to leaf 101, okay, case sensitive leaf 101, and then same password. Okay, this one we're going to go to leaf 102. So drop to the bash shell, attach leaf 102. And then on all 4 of these, we're going to show port channel summary. Okay, 7K2 sees one of the legs down, 7K1 sees one of the legs down, and then likewise so should the leafs. Okay, leaf 102 does not have connectivity to 7K1. Leaf 101 does not have connectivity to 7K2. But from their point of view, from the downstream end hosts, we should still have reachability to each other. And likewise, when we show IP ARP, the gateway MAC address is going to be the same, even though it's talking about different leafs. Now, I'm not 100% sure from the leaf. Let's look at the show IP interface brief. There it is, under Brian_VRF1. What is strange about the system is that since the VLAN numbers are essentially arbitrary now, because the encapsulation, when we go over the spines, is going to be VXLAN as opposed to VLAN, and then we're deciding on a link-by-link basis as part of the application profile what is the encapsulation that we're actually applying. You can see that it's generating an SVI number. It came up with interface VLAN 9. So nowhere in my config did I specify to use number 9, and I didn't create VLAN 9 as part of my VLAN pool. But if we were to look at the show interface trunk and then look at the port channel interface, which is port channel 2, and I think this is a cosmetic issue, that I think this command is not actually, most of this command is not even supported, because spanning tree forwarding, that doesn't mean anything. Fabric path doesn't mean anything. It's just that they ported the output of the command from the other code. What we care about, though, is what VLANs are allowed. VLANs allowed in the trunk. Okay, it's calling VLANs 9 and 10. Now, what these relate to, if we look at the show VLAN, tab, show VLAN ID, or is it show VLAN extended? This shows us what numbers these map to the VNIs on the back end, the VXLAN network identifiers. And it also shows us how is it specifically applied to the application profiles endpoint group on that individual interface. So from its point of view, for whatever reason, it shows number 9 and 10. It may just be starting at the bottom and counting up. So it said number 9 was bridge domain 1. Then number 10 was application profile 1 for endpoint group 1. And VLAN number 10 was mapped to VLAN 1234 on the port number. If we look at this for leaf 102, it likely is not going to have the same output here. Well, actually, no, in this case it is because it's a VPC, because their configs are the same. But if it's two independent physical hosts, so as part of a physical domain, they can be in different VLANs, but be in the same subnet. Okay, so they would be a part of the same bridge domain, which is effectively the broadcast domain. And this is one of the reasons that from a naming convention, they're trying to get away from the keyword VLAN, because really the only thing VLAN means is just that when I send you the frame, in the .1q header, what number am I tagging it? The number only matters between you and me, though. If I agree that it's 99 and you agree that it's 99, there's nothing to say that when you get it from me and send it to someone else, you're not re-encapsulating it as 199. And that's essentially what they've done here, is that the VLAN number no longer directly maps to the broadcast domain. The bridge domain is defined in the broadcast domain. But from a functionality point of view, you could think of it as analogous to the VLAN because it's a logical separation of the layer 2 table. Okay, same as like a VRF. They used to call it private networks, now they're calling it VRFs. When it was called a private network, it was still a VRF anyways, because it was defining who is in the same layer 3 routing instance. So if I call it VRF A, you call it VRF B, doesn't matter. It's just saying that if I run a OSPF, are we running the same instance of OSPF, yes or no? Do we have the same copy of the database? If yes, we're in the same VRF, we're in the same private network. And exactly the same thing as with the VLANs. But as you start to delve deeper into the system, it almost becomes more and more confusing as to how they specifically implemented this on the back end, because some of it seems to be almost random. But really, I think it's just that they're trying to hide all of these details from us on the front end, that we don't have to worry about it. That as long as the fabric access policies are set up to say this is the physical connectivity of the network, that's not really going to change. What we need to define on a day-to-day operational basis is what's the behavior of the applications. What are the different application profiles? Well, how are we going to group the end hosts into their different endpoint groups? Okay, am I going to do that based on the IP address? Am I going to do it based on some virtual machine information like the vCenter sends me? That's what we can do in the VM integration, which we'll talk about in later sections as we start to get into more details. Okay, so let's look at the final config of this from the APIC itself then. So again, the first section of this is the AAA authorization, keys and stuff like that, so that we don't need to worry about. Where we need to start is basically from the VLAN pool down. Okay, so we have the domain, so let me try to delete the other stuff that's unrelated, and we'll try to boil this down to our specific effective config right now. Okay, so now we have the tenant Brian, which has a VRF called Brian VRF1. It has a bridge domain called Brian BD1, which is a member of the VRF. This is basically the equivalent of saying interface VLAN 1234, VRF member Brian VRF1. Okay, but in this case, they're calling the logical construct a bridge domain as opposed to the VLAN. We then have an application profile called Brian APP1 that contains an endpoint group. The endpoint group is a member of that bridge domain, Brian Bridge Domain 1. Interface bridge domain, Brian BD1, has an IP address of 10.0.0.254. Okay, so like I mentioned, that's the same as saying interface VLAN, but from a naming convention, they're calling it something else. Okay, we then have the default config of the tenants. We have tenant common. We should have tenant infrastructure. tenant management. Okay, notice in the management VR or the management context, or excuse me, the management tenant, there's an in-band management and out-of-band management. Then this is going to define the out-of-band management is going to be the management 0 port. In-band would be like if you want to telnet directly to the APIX IP address, like that 10.0.0.254. Telnetting to that would be in-band management. Okay, we then have a leaf profile, which is calling on switch 101 and 102, ports 1/1. Both 1/1 and 1/2 are part of separate VPCs. Okay, these are the channel group names. So this is the equivalent of saying channel group 1 mode active, channel group 2 mode active. But behind the scenes, it's auto-generating a number. Okay, we then have the switch profile, which I don't know why they would call it the leaf profile instead of the switch profile. They'll call it the switch profile from the front end. So switch 101 to 102 profile, which is calling the interface selector, or excuse me, the switch selector, actually. Switch selector is saying it's leafs 101 and 102. Okay, so that's the effective config, is saying that that ports 1.1 on leaf 101 and ports 1.1 on, should be down here, leaf 102, that these are part of the same channel, which is 1-ports-1 policy group VPC. Okay, 44 to 47, those are the FEX interfaces that I had configured. Okay, they're in a VPC domain. Switchport access VLAN 1234 tenant Brian application Brian app 1 EBG Brian EBG 1. What this is saying is that on leaf 101, find the interface selector that is called from the interface policy group that is called switch 101 to 102 1-ports-1 policy group. Okay, if we look at where this is called from, this particular name, that is the template that's saying we're running CDP, we have LACP on, and you're a member of this physical domain that is then calling that particular VLAN number, VLAN 1234. And I'm trying to see, where does it say interface VPC switch 101 to 102 policy group? There. Okay, so channel group is applied under the physical link, is what it is. This is, again, the same as saying like channel group 1. And then we're going to interface port channel 1, switchport access VLAN 1234. Okay, this is the subclassification. So on the back end, when the packets are actually entering, there's internal tags that the system is adding, basically like security group tags, kind of like how TrustSec works with the ICE server, if any of you guys are familiar with that. But you don't need to define that in some sort of separate policy engine. Everything is contained within the APIC. So packet comes in, it says if it's untagged, we're classifying it as VLAN 1234. We're going to classify it in this endpoint group, in this application policy group, which is part of this particular tenant. In the tenant, it's in the VRF, in the bridge domain, in that particular subnet. So it's a very, very long-winded way of saying something that's a pretty simple config we would do from the normal CLI. But allegedly, the advantage of this now is that now that all of this construct is built, and we want to change the behavior of who can talk to endpoints that are in EBG Brian 1, it makes it easier. But to get to this point is kind of the big hurdle within the system. So take this diagram, print it out, tattoo it on your arm, whatever you need to do in order to figure out how the policies associate to each other. In my personal opinion, this is going to be the biggest learning curve for the system, is to figure out not the technology, because it's the same exact thing that we've done on other platforms, but to figure out what is their naming convention of what do these policies actually mean, and then to figure out how do I read this from the GUI or how do I read this from the CLI. Without knowing how these things connect to each other, it's going to be nearly impossible to do that.